Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about slope, specifically dealing with linear functions. If this is your first time to the channel, thanks for coming. If you're coming back, thanks so much. I appreciate it. If you like it, leave a comment. Give me a like or subscribe to the channel. I appreciate your support. All right, let's talk about the definition of slope. First of all, what is slope? We will define slope as our m values. M is often used to define slope. Doesn't necessarily need to, but in your algebra books, you'll often see m used to describe slope. And slope, you probably have heard the rise over run comparison. Rise just means the change in the vertical change, and the run means the horizontal change. And when I say change, this triangle, delta, we call it a delta. We have delta x and delta y. That just means the change in y over the change in x. And when we mean change, we mean we've got 2 points, right? In our case, we've got x1, y1, and x2, y2. Those are just 2 points. And they're generic, right? We're not putting numbers in for x and y, so they're just 2 generic points, and we put little label identifiers, the 1 and the 2, so we know which point is which. When we go from one point to the next, we can go from point 1 to point 2. How does the x value change, and how does the y value change? That's really all we're looking at for slope. If we look at our points on the graph here that I've drawn, our x1, y1 is here in the purple, and the x2, y2 is there in the green. So when we move, currently when we start at x1, y1, that point, the x value is right here. So it's this distance from 0 on the x-axis. When we move, we go from x1 to x2 as far as our coordinate change when dealing with the x. So that's really our change, right? That blue that I just highlighted. And that blue can be found by taking x2, whatever x2 is, and subtracting off the x1 portion. That just leaves us with the area in blue that I just highlighted in pink. So that's x2 minus x1. That's the change in our x coordinates. And notice x2 minus x1 is exactly what we have here in the bottom of our definition. So we take that same idea and we say, well, how does our y change? Well, we start with y1, and we move to y2 from y1. So to get the difference there, well, we can take our y2 and subtract off the y1, and that gives us the distance moved from y1 to y2. So y2 minus y1, that gives us the movement vertically, or the movement in the y's, or the change in y. So that's why we say the movement, the vertical movement, you can see the vertical movement is right here, moving from x1 to x2, and the horizontal, or the vertical movement, did I just say vertical? I may have just said that wrong. The horizontal movement is going from x1 to x2. The vertical movement is going from y1 to y2. That's where we get the rise over run. That's it. That's where this whole formula comes from. y2 over y1 over y2 minus y1 over x2 minus x1. That's the formula for slope. And by the way, the denominator cannot be equal to 0. x2 minus x1 is the denominator. It can't be equal to 0, or our slope is undefined. So here we have 2 points. Let's find the slope between these 2 points. we have the blue point and the red point. The blue point is 0.1. The red point is 0.2. It doesn't matter. You could switch them around and identify the red is 0.1 and the blue is 0.2 if you wanted. You get the same answer. But for our purposes, I've called the first one 0.1 and the second one 0.2. So what is, I've also marked my x1, x2 so we can easily identify the numbers. So what is y2? Y2 is the red, so I have 4. I'm literally just writing these down, right? So I have 4 minus y1. Y1 is -1. And in the bottom I have x2, which is the red one, so -2, minus the blue x, which is -3. The negative and the negative give me a plus in both of these. So I really have 4 plus 1. And in the bottom I have -2 plus 3. So 4 plus 1 gives us 5. -2 plus 3 give us 1, which just gives us 5. So we have a positive slope of 5. 5 is a positive number. We can see that if we looked at the graph, because we can see that starting from the point, the blue point, if we were to get to the red point and say we were driving there, we'd go right 1 unit. That's the change in the x, which you see in the denominator. And then we would go up 1, 2, 3, 4, 5 times. 5 units change in the y. So there you get 5 over 1, which is 5. So I've got a question for you. Does it matter where we put the y's and the x's? So the first y2 minus y1 over x2 minus x1, that's the formula that you're given, that you will see traditionally in a book. But what if we put the 1's first? Notice the 1's are second in the formula. What if we put the 1's first? And what if we did y2 minus y1 over x1 over minus x2? y1 minus y2 divided by x1 minus x2. What if we put the 1's first and the 2's second? Will we get the same thing? And what if we kind of mix it up? What if we put the 2's first on top, but we put the 1's first in the bottom? Do we get the same thing? Does it matter? Well, let's quickly run through these, and we'll see if it matters. So we know what this first one is, right? This is 4 minus a minus 1 over -2 minus a minus 3. We decided that gave us 5. Let's do the 1's first and see what we get. y1 is the blue. So that gives us -1 minus 4, the red. And x1 is -3 minus x2, which is -2. This gives us -5 over 3, and this gives us a plus. Minus and minus gives us a plus, so -5 over -1. Which is just 5, because the negatives cancel. So we did get the same thing. Interesting. So apparently it doesn't matter. Actually, it doesn't matter. That's the whole point of this exercise here. It doesn't matter if you put the 1s first or if you put the 2s first. Let's see what happens when we swap. We put the 2s first on top, put the 1s first on the bottom. If we put the 2s first in top, we've got a 4 minus a minus 1. And then in the bottom, if we put the 1s first, we get -3 minus a minus 2. This gives us, in the top here, we get +5. And in the bottom, we get -1, which gives us -5. This is not the same. We get the negative of what we really should get. So the moral of the story is here, it is okay to put the 2s first or to put the 1s first, but you've got to stay consistent. Whatever you do in the top, you've got to do in the bottom. You can't do this 2 first on top and 1 first on the bottom, or vice versa. Interesting question, huh? That's what I thought. All right, let's do an example. Find the slope between these 2 points. So the blue is the 1 and the red is the 2. 0.2. Let's see what we get here. So y2 gives us -1 minus the blue one, which is 4, and the x, red x, which gives us 2 minus x1, which is -3. Here we get to -5 over negative gives a positive, so -5 over +5, which gives us a -1. That's a negative slope. So above we had a positive number. As a result, that was a positive slope. This is a negative number, so we have a negative slope. Here's another one. Again, blue is 0.1. Red is 0.2. y2 minus y1 gives us 4 minus 4. And x2 minus x1, we get 2 minus a minus 3. Minus a minus gives us a plus, so we get 0 over 5. 0 over 5 is what? It's 0. So we have a 0 slope. That doesn't mean there is no slope, because 0 is a valid number. It just means the slope is 0, meaning there's no change vertically. So you have a horizontal line. Something that's completely flat. Doesn't go up or down as you go from right to left. Let's try one more. Again, the blue is 0.1 and the red is 0.2. So we have -1 minus 4 and 2 minus 2, which gives us -5 over 0, which gives us what? We have a 0 in the denominator. That's a big problem. That can never happen. So this is actually undefined. So we have change in the vertical, but we don't have change in the horizontal. So that looks actually like a vertical line. Speaking of vertical lines, let's look at the graphs of these 4 different possible slope categories. So as we're looking at slope, we move from left to right in the graph. That's important. When you look at a graph, you're looking from left to right as you're considering slope. So as you move left to right, if you're going uphill, moving left to right, think of a person walking, going left to right to go uphill, that's a positive slope. So you get a positive number, like 5 is a positive number. Or if you're going downhill, moving left to right, that's a negative slope, and you'd have a negative number. if you computed the slope, like -5/2, for example. Now these are just examples. They aren't really the slopes of the lines that I've drawn. Except for these last two. Those are. So if the slope is 0, that means you have a perfectly horizontal line, meaning there's no movement up or down. So you have a 0 in the up or down movement spot in the numerator, and then you have movement in the denominator. So 0 over some number is always 0. That's a valid slope. It just means you have a horizontal line. And the last one is the undefined option. So think the person's walking left to right and he can't walk because the person's trying to get through and the person can't get through the wall, right? Moving left to right, he can't rock climb. But he can totally walk straight. He can go downhill or they can go uphill. But they just can't go through the brick wall. So in these cases, where you have a slope that's undefined, it doesn't exist, the slope doesn't exist, you have a 0 in the denominator because there's no movement left to right, they're just moving up and down. So the slope is undefined. Hopefully this helps.